gist of it, we're on the right track. And then I have the rest of the semester to kind of address some of the things that are that you maybe not catching the first time. Okay, so first question, every time you ask yourself, right, does the order matter? How do you know order matters, right? Are there, right? This is on page 58. Are there specific positions, roles? Is there a picture, right? Picture or image? Is it a password? We would all agree that with passwords, order matters, right? And so that's basically the question you want to ask. Like, is it just, I just need a group of a bunch of people, or would it matter whether I pick the one person first and the next person second? Okay, so that's basically the question you want to ask yourself. If order matters, then you're in the permutation camp. I will though add a note here, right? Use fundamental counting principle, right? So for example, right, you can fill in, right, 4, 3, 2, 1. That's the kind of thinking you're allowed to use, the one we spent most of the time on, right? We spent a lot of time doing this kind of stuff. And then everything in between, right? Things staying together. We had to maybe start with a certain letter, end with an even number, things like that. All of that is still, I can't fit that all in here right now, okay? So keep that in mind. Next question you want to ask yourself is, are there some items that are identical? Okay, so for example, marbles, balloons, some kind of decoration, etc. Something that you know will look the same. Cards, I would not put cards under that, because if you have a deck of cards, even though there's 26 reds, for example, every single one of those 26 is different. So be careful when it's cards from a deck, a standard deck. Don't be falling for that. It's like, oh, there's 5 red cards, right? There's lots of identicals in there. They're not. So be careful there. If the answer is yes, we divide by R factorial, right? Where R is the number of identical items. Also look for conditions. So even if you say yes, look for additional conditions, right? So that by this I mean, like for this one right here, is even number, starts with a particular letter or symbol, right? Oops, you can't see that, my bad. Right, for the conditions, is it an even number? Does it start with a particular letter? Does it have to start with an S or a C? Does it start with a vowel? Right, all those things. Is it an odd number? Does it have to be at least a certain number, like 3,000 or more? Things like that, you have to watch out. If it says and, then we just multiply the occurrences. Just multiply. If it says or, we add. So and is times, or we add. And sometimes they're implicit. So don't be looking for, oh, there's a bunch of ands here, so I'm going to multiply this, 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 and this. Kind of make sense of the question and make sense of what we've been doing so far. Okay? All right. So this is a good flow chart. I thought I would add that. And now we're going to go, this is kind of like a warm-up to the homework that I'm going to go over so that you're able to kind of think about this as we do this. All right, let's go to 62. So we're kind of going to I will have some permutations, but I will kind of camp on combinations today for the most part. So let's go to 62. Were we okay with one? There are 5 swimmers in the first heat of a race. There they are. How many ways can swimmers finish first, second, and third? I'm just going to answer that right here. From the 5, you would pick 3, right? Or you go 5 times 4 times 3. Same thing. That's how you would find the answer there. So order does matter because finishing first, second, or third, right? It does matter. Order does definitely matter there. How many ways can 5 swimmers qualify for the final race if only the top three swimmers advance? So it's technically just a group of 3. How many groups of 3 can you have there? You don't really care about first, second, and third, just a group of 3 at the top there. So in this case, I would go 5, C3. Okay? C3, there are no positions, so that's what you would do there. I'm not going to give you the answer because I don't want to type right now. It takes forever with these calculators. But that's how you would get it, right? A piano teacher and her students are having a group photo taken. It's probably a little bit of a hint here, but don't right away think it's combinations. Don't go for it right away. Keep reading. There are 3 boys and 5 girls, so 8 in total. The photographer wants the boys to sit together and the girls to sit together for their first pose. How many ways can the students and the teacher sit in a row, right? They're sitting in a row and 9 chairs are there for this pose. So some of you might read this like, oh, this is group, so it's combination. However, you're sitting in a row and you're arranging for a picture. That is permutation, okay? So picture taken. Perms and comps, that's the short way to refer to this unit, perms and comps. Okay? Permutations, combinations. So in a sense, 1, 2, 3, 4, 5, 6, 7, 8, 9. A piano teacher and her students. I see. I now know, Ojasvi, I know your question now. But anyway, it says 3 and 4, 1, 2, 3, 4, 5, 6. So I have in total 10 because the teacher is part of it. So right now, in this case, you can argue that the question was a little vague, but it's the 3 boys sitting together. And then there are 5 girls, right? 5 girls. So 1, 2, 3, 4, 5. They are together. And the teacher, technically, the way this question was worded is not to be part of the girls in this case. But if you read it that way, you have a very fair point. Today you have a fair point if you put the teacher in that mix. However, it's not a fair question, let's put it that way. So if you put the teacher in with this group, then there would have been a group of 6 there, right? 6 girls. So don't forget though, no matter what, zooming out. So when you zoom out, you count the bubbles, right? 1, 2, and 3 in my case, okay? So this answer would be 3 factorial, 5 factorial, and I like the zoomed out. This is zooming out. I like that at the end. Then you know for sure you're not going to miss it because most students get the fact, oh yeah, there's 3 factorial, 5 factorial. So if you put the teacher in with the girls, then it's 2 factorial at the end, okay? So it wasn't a fair question. I get it. I get it. As long as you understand what's happening, why I'm doing it this way, okay? Okay, next. How many 5-person committees? You know what? Remind me, I'm going to go back to the flow chart. When it goes to combinations, I'm going to go like making groups, teams, committees. That's classic, okay? Classic combinations, okay? Group of 6 women. Well, read the whole thing though. Read the whole thing. 6 women, 4 men under each of the following. There are no conditions. So committees, combinations, order is irrelevant. So for A, it would simply be the total of people available. I've got 10 total. Okay, so you simply you say I have 10 people and I need to make committees of 5 at a time. So it's 10, choose 5. That's it. Okay. I might add something to this to prepare you for a curveball. There must be exactly 3 women. Sometimes students just know how to write the numbers. I would say this, you must have a 5-person committee. So if you have 3 women, then you got to also make sure you have 2 men in there. Okay, you got to have the committee of 5. So you got to split this up now. So there are 6, and from the 6, you're going to choose 3, and from the 4 men, you're going to choose 2. That's how you would have to do this one. You have to have the and, the multiplication between those two basically statements, okay? And you get an answer there. C, there must be exactly 4 men, right? So you have 4 men, and therefore you have 1 woman in there. So from the 4, you choose 4, and from the 6 women, you will just choose 1. And remember, the 4 and the 1, I got my 5, right? 4 and the 6, I've got the 10. So that still adds up, right? It still is doing what we're supposed to do here. D, there can be no men. Okay, so 0, so therefore all 5 have to come from the women camp, right? So then it's, if you want, this is not necessarily needed for choose 0, but I like it to be there because you think about what would happen if that wasn't a 0, right? So 4C 0 and 6 choose 5. From 6 women, you choose all 5 to be part of that. So that's how you would find that. There we go. And then E, there must be at least 3 men. That one, let me see, I need probably a bit more space. And my key may have done it in a different way, but my approach is going to be this. At least 3, so that means you can have a group of 3 or 4, right? You can't have more than 4 because we only have 4 men available. Okay, so you can have groups of 3 or 4 men. That's what we're talking about here. So maybe I'll just go this way. Option 1 is 3 men, 2 women. Or, no, maybe I'll do it this way. Hold on. Or 4 men, and therefore I need 1 woman in that group. So that if you did these 2 cases and you added them up, you would have at least 3 men. You would consider all of those cases. So that's where, when it's at least, it usually gives it another twist to it. You really have to think it through. Okay, so let's do this. 4 choose 3, and 6 choose 2, or okay, the other case where you from the 4 men you choose all 4, and from the 6 women you choose 1. So you're considering both cases that are possible here. What's 4 choose 3? Is that 4? Yeah, this is 4 times 15 plus, this is just 1 times 6. So this would be 60 plus 6, that's 66 groups. Is that what my answer key said? Yeah? Okay. Phew. Did I do it differently on my answer key? Direct and indirect? I find direct is probably now about the same amount of work than doing it indirectly. What does indirect mean? Is when you subtract from the total. So I would take my 10C5 and I would subtract groups that have just one in it, one man, and then two men, right? I subtract those cases, then I'm left with 66 as well, right? So maybe I will leave it for today, otherwise you might get overwhelmed. Are there a lot of these cases? No. Most of the time, the at least, listen to this one, can be dealt with if you go total minus the case that doesn't have any. Most of the time it's at least one. So you'd go total minus the groups that have no men. In this case, it would have been D here, right? If you subtract the total number of groups minus this one, you'd have all the groups that have at least one man in them, okay? So let's go on to the back side. 4 you cannot do yet. You cannot do yet. After today, hopefully you will. Question 5. Which one was it, Jamie, that you asked me about?
You already answered it.
Oh, I did? Okay.
Thank you.
No problem. 5. That one, consider the word funny. How many different arrangements using all the letters of the word with no condition? This word, over time, the province has gotten rid of because students thought when it says no condition that literally like you don't even have to worry about identicals. But you always have to worry about identicals. You have to divide that out. We don't count that as a permutation. So it may or may not be there, but regardless, this is having to divide that out. So 1, 2, 3, 4, 5. So you'd have 5 factorial divided by, there's 2 n's. So I'd have to factor that out, right? I have to divide that out. So n is equal to 5, and there's 2 n's. And so that's what I do with that. And the province has some crazy long words. Sometimes they have like 20 letters, and they've got multiples of a lot. So just take your time, count, and double count. Maybe triple count, okay? B, how many different arrangements? If it must start and finish with an N. Okay, let's do that one here. 5B. 1, 2, 3, 4, 5. Okay, it must start and finish. So there's one N here and another N there. Okay, so you just go 1 and 1. So technically at the beginning, you have 2 N's available. At the very beginning, to fill in this slot, you've got 2. But we won't count it as 2, we just count it as 1. Because it doesn't matter if you put this N over here or this N over there, it doesn't matter. We will not count it as 2 permutations. So it technically just goes 1 and 1 then, like this. And so that would be if you're from 5 you're down to 3, right? So it's 3, 2, 1 for the rest here. So this would be basically 3 factorial. 3 factorial, which is 6 ways. That's how I would deal with it. Okay. 6. At Children's Hospital City, 1 million people running a charity. There's a lottery called Lucky 6 to raise money. Players choose 6 numbers from 1 to 66. The player wins if the 6 numbers are chosen, drawn at random. How many ways could the player win? How many ways could you lose? How many ways are there to win in a lottery? Uno, right? Just one win. There's only one way to win. You got to pick all the right numbers. How many ways can you lose? A lot of times, right? So how would you do that? From the 66, we got to choose 6 numbers, correct? And we're going to subtract the one time that you can actually win. Okay? This is you winning. So obviously if you're interested in the losing tickets, we're going to take all of possible combinations we can make. From the 66 numbers, we pick 6. What is that, by the way? That's a lot. That's 90,858,768 minus 1. So that's 90,858,767. You go home and you tell your parents this. Don't buy lottery tickets. Anyways, you still do because you never know. Would you play this game? Why or why not? Yes, I will, because at some point I will win. You do whatever you want to do there. Let's go over to 64. There are 7 boys and 13 girls, so 20 total. A group of 5 is created, emphasis on the group, but let's keep reading. 5 is needed to make that art exhibit. How many different groups of 5 students with at least 2 boys can you choose from? So 7A. At least 2. What does that mean? In this instance, groups of 2, like 2 boys, or 3 boys, or 4 boys, or 5. Right? At least 2 means 2, or 3, or 4, or 5. I'm not going to deal with, I'm just going to pick one of these methods. I'm not going to do both. Because, so what does that mean? There's still, my options are no boys in there, 1 in there, right? This would be cases we don't want. We don't want the cases where there are no boys or 1 boy, right? That's basically what this statement is saying. Does that make sense, guys? I know it's early in the morning, but this at least 2 is, this is what I want. This is what we want. This is what we don't want. The groups that have 0 or 1. Which one do you think is going to be more work? I think this one is going to be more work in this particular case. So I'm going to deal with this. I'm going to go total minus 0 boys, therefore 5 girls, minus 1 boy and 4 girls. Okay, that's what I'm going to, that's my indirect. This is indirect. Every time you subtract, we call it indirect reasoning, like we're going about it in a different way. We're getting rid of the things we don't want. Okay? What's my total in this case? How many groups are there possible? We have 20 available, 20 people available, so we'll go 20, choose 5, correct? That's my total. That's like no restrictions. I don't care what the mix is. 20, choose 5. Minus. Some of you already did this, but if you didn't do this, I'm going to give you 1 minute for each. Can you write this out using combination? Or would you be able to do that today? Write this out using combination. Give it a try. So 2 minutes. If you haven't done it yet, I'm asking you to do that right now. Often on an exam, at least one. So here in this case, it would be 7 choose 0, right? 7 boys, we choose none of them. And so, and from the 13, you choose 5. Students do all kinds of wonky things here. Sometimes they go plus, they add them up. But usually there's, in this case, we go minus. You got to go and here. We got to have 0 boys and 5 girls in this case. Minus 7, choose 1. And 13, choose 4. I'm a strong believer, maybe my key doesn't do that, in writing out what you're going to do first and then do your combinations. Because if you don't, you will lose track, okay? And you're like, what's happening here? So let's do this here. This would be 15,504 minus, this is just 1, 7 choose 0. 13 choose 5 is 1287, so that's multiplying. 7 choose 1 is 7. 13 choose 4 is 715. So we've got 15,504 minus, this is just 1287, and this is 5,005. And now we have our final answer. $9,212. Is that what my key says? Anyone? Yeah, it is. Thank you. Groups. This is indirect reasoning. I'm not going to do direct. This is the only one that I'm going to show you. Okay, direct would have been figuring out the two, right? So if I go up here, figuring out the cases where there's 2, figuring out the cases where there's 3, 4, 5, and then what would we do with these answers? We would add them up. Okay, we would add them up. But as you can tell, it's going to be more work. So choose whatever works for you. 8. How many different 5-card hands that contain at most 1 black card can be dealt to one person from a standard deck of cards? And there's the infamous at most, right? Here's the at most. At most 1 black card is what you're allowed to have. What does that tell us? If you read that, what are you going to translate this as? At most 1, right? So you can have 0 black cards, right? Or 1 black card. That's what we want, right? Does that make sense? We need to consider 0, because as long as you don't surpass 1, you're doing fine. So at most, you can't surpass it, right? You want to translate this a different way? No more than 1. That's another way of translating that. At most as no more than, okay? So let's consider these 2 cases. I'm going to ask you to do this yourselves. There's a deck of cards on the back. Imagine this is an AC right now. So we're going to go 0 black cards. What's the opposite of black cards here? Like, what is the alternative? Red, right? In this case? That's like if it's hearts, then the alternative is no hearts. If it says aces, then the alternative is no aces, right? So that sometimes that's the only deck of cards is like that, because we're supposed to know what's in there. So 0 blacks, 5 reds, or we're going to have 1 black, 4 reds. Those are the only 2 cases we're going to consider. Can you do this? From the 26 black cards, I'm going to choose 0. And from the 26 red cards, I'm going to choose, where's R coming from? Anyways, choose 5. And guess what? 26 and 26 adds up to 52, perfect. 0 and 5, that's my hand of 5, right? My group of 5, my committee of 5, right? Or 26, choose 1. And I'm drawing a blank here. 26, yeah, got it. Choose 4. 26, choose 0 is just 1. 26, choose 5. I need my calculator for that. 65, 780 plus 26, choose 1 is just 26. 26, choose 4 is 14,950. So you get 65,780 plus 26 times my previous answer, That's a lot. That's 454,480. And please tell me this is right. Yeah? Okay. That's how many hands would have at most one black card. At most. How many hands can you make? If I just asked you, how many hands of 5 can there be made with a deck of 52 cards? It's just 52, choose 5. It's 2 million and something, right? 2,600,000, more or less. So a lot less because we're restricting, right? We're only interested in at most one black card. I'm going to add a question right now for you. So add 9 here. If you don't have space, there's blank pages after this. Okay? How many hands of 5 can you make if you have to have 1 queen, 2 spades? That's all I'm going to say. 1 queen and 2 spades. How would you write that? If I asked you to do that. This is exactly. You don't have to worry about the or. You don't have to make up cases. There's only one case to consider. It's exactly. Let me put the word exactly there. That is the one I'm going to use for you, right? The province too, they'll say has exactly. And even if it's not there, if it just says 1 queen, 2 spades, like that's all we're considering. We're not saying at least 1 queen or at least 2 spades. It's just like 1 queen, 2 spades. How many hands could you have? Give it a try. Give it a try. I honestly, don't solve it. Don't give me the final answer right now. Just write it down in combination notation. How would you even do this? Right? Maybe you can squeeze a mark out of it. Maybe 2 marks out of it, right? So try this. If I do A, maybe you'll figure out B. I need 1 queen, okay? How many queens are there? 4. I choose 1. And how many spades are there? Spades? 13, right? It's a whole suit. Choose 2. But how many do I still need? Like if you think about it, this is 1 and 2. That's only 3 cards so far, right? I still need something. Choose 2, right? I need to choose an extra 2 to make this work. What do these numbers have to add up to, like the first numbers here? What should they add up to ideally? The 4, the 13, and this should add up to 52. That's my total. I have 52 cards. Fun stuff, eh? I know. So to do this one, when it's like a 3 like this, you're not going to see more than that, I don't think, ever. But basically what you do is you go 52 minus 4 minus 13, and that's how you insert that. That's 35. So these are my, this would be the queen, this would be the 2 spades, okay? And this is other. I call this, in this case, we had to come up with another one. Like, you have to still fill in your hand of 5. You've taken care of the queen, you've taken care of the spades. Now I need, from the 35 other cards that are there, you figure out, you need to pick 2 more from that pile. Okay? That tricky one. I know it's a tricky one. What about the next one? 2 faces, 1 ace, and a 7. So, how many faces are there? How many face cards? 12. Deck of cards. Every suit has 3 faces, right? The Jack, Queen, King. And so since there are 4 suits, you have 12 faces. I would have that on my study sheet if you struggle with it. I would have the basics. I'll give you a little cheat reminder for that one. 2 aces. So there are 12 faces. I choose 2. There are 4 aces. I choose 1. How many 7s are there? 4 7s. I choose 1. Is this complete? 2, 1, and 1. I so far only have a hand of 4. I need another. Another card. What would this number be right here? 52 minus 12 minus 4 minus 4, right? So that would be 20, right? So this would be 32 here. 32, choose 1. And there you have your hand that would fulfill that requirement. So this is 32, and that's how I came up with that. So, what should you learn from this homework check? The first thing I want to tell you is that the first numbers always add up to your total. How much do you have in total, right? The second numbers, they have to add up to whatever group you're making. Like, is it a group of 5? Is it a group of 10? What are you making, right? A hand of 5. So you got to make sure you fulfill that. Okay, all right. You want the cheat for the deck of cards? Here it is. This doesn't take up a whole lot of space. I'm going to do this right at the back of this booklet. So basically, there's 52 cards, and I go 26 black cards, 26 red cards. Okay, and then you have a split. You've got your spades and clubs, and you've got your hearts and diamonds. Each one of them has 13. Okay? So I will say this though, for spades, you've got 13 cards, and I'll just do the breakdown for the first one. Every single suit has 1 ace, has numbers 2 to 10, and has a queen, no, sorry, Jack, Queen, King. Not that it matters a whole lot, but Jack, Queen, King. If you have to do that, if you have to write out the same steps, Ace, 2 to 10, Jack, Queen, Queen, King, for all of them, do it if you must. But I'll just show you the first one. These are the 13 cards that are part of this. Okay? And a little note, there are on the side here, 12 face cards, 12 faces, 4 aces. How many numbered cards are there? Numbered meaning from 2 to 10. Indirect reasoning. 52 in total. Take away 12. We're down to 40. Take away 4. We're down to 36. So 36 numbered cards. This is it. I'm not going to go in more detail on this. If you're really good at memorizing your deck of, if you know your deck of cards, then maybe don't use up this much space and make it really small. Okay, hopefully that'll help you. There won't be a whole lot of deck of cards, but every once in a while the province does, or I do, right? So if you don't know your deck of cards, it's gonna hurt you. All right.